Okay, last example, determine the equation of a tangent to this curve. They want the tangent to be at the point x equals 1. Okay, we're going to derive this function first, then plug in our x value to find out what we're going to have in terms of an equation. And then there's going to be a part B to this. So, we're using our sum and difference rule, if you noticed. Sum and difference rule, plus our constant rule, plus our product rule. So we're using all four in one question. We'll go through it a little quicker. This 3, now technically this is a -1, so this is a constant multiple. Oh, we're even using that rule, 5 in 1. This is 3 times -1, which will give us -3 when we're looking at f prime x, when we're deriving this. 3 subtract 1 gives us 2. So that's the derivative of the first function. According to our sum rule, we just add. Same idea. We bring our 2 down and multiply by our constant. So we're going to get 6x. And 2 subtract 1 is 1. We don't need to do anything with that. Derivative of the number 2 is 0. So we get -3x squared plus 6x. Okay. Now, once we have that, to find out what our slope is going to be here, we need to plug in our value or at a certain point. Okay. Now, we were trying to find it when x was equal to 1, so I'm then going to take f prime at 1 is equal to -3, 1 squared plus 6 times 1. This becomes 1 times 1, which is 1 times -3, which is -3, plus 6. Our slope is 3 at x when it equals 1. Okay? They want the equation of that tangent at that point. If you guys remember, y equals mx plus b. We know the tangent is going to be a linear function, a straight line. Our slope is 3. We just discovered that. We're going to need to find a y value with our x value. Our x value is 1. So when x is equal to 1 in our original equation, that's way up here, what's our y value going to be? Well, we can quickly plug this in. I put 1 here, it's still going to be 1. So we get -1. This is going to be plus 3 minus 2. -1 plus 3 gives us 2. 2 minus 2 is 0. Our y value when x is 1 is 0. So that's our coordinate. That's the point on the curve of our cubic function that we're touching. So it's going to touch at this point. Our slope is 3. Our y value is 0. So we plug 0 in for y. We plug 3 in for the slope. And we plug 1 in for the x value to solve for what our y value will be. 0 subtract 3 is equal to b. b equals -3. So the equation of this line, y equals 3x minus 3. That's the equation of our tangent line at the point when x equals 1. Now part B of this, part B asks us, okay, it asks us when the tangents are horizontal, okay? So let's do part B. Horizontal tangents. We might have none. Remember, we have a cubic function, so we probably have something that's going like this or kind of turns and goes like this. We want horizontal tangents here. So if we're looking for horizontal tangents, we go back to our derivative function, which is very important here, f prime x. We're going to take this value, and when something's horizontal, anyone know what the slope of it is? 0, okay? So that means we're going to be looking for a value of 0 there. So we're going to take this function, f prime, that's supposed to be a prime, x, -3x squared plus 6. When something's horizontal, our slope is 0, so we're going to replace our f prime x with 0 is equal to -3x squared plus 6x. There might be multiple values, so we're going to factor or find out values of 0, or we can factor out -3x, and we're left with x minus 2. Okay. We now have two values, or think of it as two terms. If either of them are 0, we know we're going to equate to a 0. So there's going to be 2 points along this. We'll have 2 horizontal slopes of our tangents. We'll split this into two equations. If you guys remember this old style. 0 equals negative 3x, and 0 equals x minus 2. Well, in this case, x is 0, and in this case, x is the value of 2. Okay. So what that means, if we were to plug those in, we know we'll have horizontal slopes there. And in fact, they may even ask us for the coordinates. What are those two coordinates? We'd have to take these values of 0 and 2 to find out the coordinates and plug them into the original part of the equation. So we plug in 0 and 2 from one of our x's,
Please pardon the interruption.
and we've done.